Problem 1 starts by giving us the absolute function is defined by the multipart rule. The absolute function of x is x if it's greater than or equal to 0, and absolute value of x is equal to negative x if x is less than 0. Then just a graph of what y equals absolute value of x looks like, and then it asks us to calculate the absolute values of 0, 2, and negative 3. There they are. The only one that changes is negative 3, and it's going to be positive 3 now. And then it asks us to solve for absolute value of x is equal to 4, absolute value of x is equal to 0, and absolute value of x is equal to negative 1. So we can use the chart up there and our knowledge of absolute values, and we basically just solve for 0 for all of them, and you get x equals negative 4, x equals 0, and x equals 1. And then it's asked us to sketch the graph of y equals 1/2 x plus 2 and y equals the absolute value of x in the same coordinate system. Find where the two graphs intersect, label the coordinates of these points, and then find the region bounded by find the area of the region bounded by the two graphs. So here's my coordinate plane. Each of these lines just representing 1 unit. Like that. And then you have our line y equals 1/2 x plus 2. I found that by just getting the x and y intercepts, plotting them, and then drawing a line across. And then for the absolute value one, you could plug in a table for y is equal to the absolute value of x, but you just look at it and know that for that graph, it's got a slope of 1 and it's an absolute value. It doesn't have any transformations, so it just starts at 0, 0, and then has a slope of 1 and negative 1. Starting at the origin, so that's what it looks like. So now what we have to do is find where the two lines intersect here, and then find the length for the base and the height of the triangle that it forms, divided by 2 in order to get the area squared, the area. So we know that y is equal to the absolute value of x, and that's going to be y is equal to x and y equals to negative x. So basically we set x and negative x, which is our y values, equal to our equation of the line to find where they intersect. So we have negative x is equal to 1/2 x plus 2. You just solve for x, and you end up getting x is equal to negative 4 over 3, and of course the absolute value of negative 4 over 3 is y, so that's our y point. And then we want to solve for positive x equals y, and then so you got x equals 1/2 x plus 2, solve for x, and then you get x equals 4, and the absolute value of 4 is y, so that's our second point. This is what that triangle looks like. I've just kind of isolated it from the graph here, drawn the points, and then we need to find this length and this length. I just drew two right triangles here, and it's going to be an equilateral right triangle, so it's just 4/3 on each side. So in order to find the hypotenuse of that triangle, you just get the square root of 4 over 3 squared plus 4 over 3 squared, and you end up getting 4/3 root 2 for the length. And then you do the same thing over here, using 4, 4 as the coordinates, and you get 4 root 2. Then you just do base times height over 2. You get 4/3 root 2 times 4 root 2 over 2. 4/3 times 4 is going to be 16 over 3. Root 2 times root 2 is just going to be 2. And then all over 2, so 16 over 3 times 3 over 2, or 2 over 2, excuse me, the 2's cancel out, and you're left with 16 over 3 units squared.